Question number 12. Have I got the answer? Got this answer, the fourth answer. Question number 12. It's straightforward. Next, try question number 14 and 15. Sham, okay, right? The 12th. So in the 14th one, what is the first thing you have to do? So consider one of them to be larger. Okay, we don't know which one is larger. I'll consider E1 is greater than E2. Now, have I got an idea what to do next? You have to find the current in this circuit. You have to find the current. So, what is the current? What is the direction of current? Clockwise or anti-clockwise? The sense, is it clockwise or in the anti-clockwise sense? Clockwise. Both of you, Amna and Shahama, are you all clear with this current? The current I have found. Here I applied in the clockwise sense. So E1 is greater than E2. Therefore, it's E1 minus E2, which is equal I into R across this resistor, I into R across this resistor, therefore 2 times. And then I found the current I. Okay, Amna, are you clear with this part? E1 minus E2. Okay, so next on the other side, we have to include all the potential drop. So in this clockwise sense, Here we have a potential drop because we have a resistor, it is IR. Here also we have a resistor. Now the current is flowing like this, IR. Okay, that's why I have taken it two times. Oh, you can just add IR plus IR. Instead of that, I considered it as two times. Okay, after that I found I. I'm now okay with that. So now, next, are you all clear with these arrows I have marked? These two arrows. Shahama and Amna, clear with these two arrows. Across this arrow, we have potential drop. So when there's a potential drop, I have to mark the arrow in the opposite direction to the current because it is opposing. Okay, so here we have a drop, here we have a drop. Now, you can use any of the sides to find what is V naught. You can either use your right hand side or the left hand side. So let's go or let's find out using both direction. V naught is equal, I'll choose E1. E1, is it plus or minus? It is minus I into R. So E1 minus E1 minus E2 over 2R into R. Simplify, then you have 2E1 minus E1 plus E2 over 2. So this is equal to E1 plus E2 by 2. Okay. Or now I'll go from this side. When I go from this side, both the arrows are in the same direction. So I will have to add them together. So V naught is equal E2 plus IR. So E2 plus E1 minus E2 over 2R into R. So this is equal, simplify, 2E2 plus E1 minus E2 by 2. So E2 plus E1 by 2. So irrespective of the path you choose, you should come to the same final answer. Is it clear? These two methods. Actually, not two methods. It's actually two uh, possibilities. You can either choose this path or this path. Okay. The sign plus or minus depends on which you choose. Both of you clear? Try the next question. Question number 15. In your book, is it printed? The voltage across this? And your one, it's given as 4. Sorry, the answer is 4. Now, what is the voltage across AB? Is it 18? Okay, now first tell me, will there be any current through this resistor? Will there be any current through this resistor? Will there be any current through this resistor? No, because just think, uh, there is one very important thing. The amount of current leaving the battery should enter the battery. Okay. If some current flows through this resistor, then there is no way back. There is no way back to come here. So across this resistor, you won't have any current flow. If you had one more resistor somewhere over here, or you had a resistor over here, then there will be a current flow. Okay, did you get my idea? In this case, there won't be any current flow. So here, the first thing, no current flow. If there is no current flow, what can you tell about the potential on either sides of this resistor? They have to be same. Okay, both of them have to be same. So to make things easy, I'll consider D as grounded. D is grounded. So if D is grounded, this is also ground. This is also equal to 0. Then VB minus VD is equal to 18 volt. So first statement is correct. Second, they say, sorry, do you all know what is the voltage here? Can you check? In the second one, they say VA is not equal to VD. But that is false, right? Both of them have to be equal. So this is wrong. Third, it says VB minus VC, VB minus VC is equal VB minus VC is equal to 6 over 124 volts. Let's check that. Without this value, I don't know. The fourth one says VA minus VC. VA minus VC is equal to minus 6 volts. So we know that VA and VD are having the same potential. Therefore, this is 0. And VA is equal to VD is equal to 0. So 0 minus, what is VC? VC is 6 volts. So this is equal to minus 6 volt. So this is true. Fifth one, they say VA minus VD is equal to 0 for R equals 0. This is incorrect because for any value of R, this should be for any R. So the answer has to be 4. Okay. Then anyhow, first and third is wrong. If you know the value only, you can get the value. Okay. You can get the answer here. So Amna and Shaham are clear with this question. Just check the past paper and see what is the value that should come over here. 12. So VB minus VD is equal to 18. That is incorrect because it is equal to VB is 12, VD is 0, 12. VB is, what is VB minus VC? VB is 12, VC is 6, therefore that is equal to 4. This is correct, therefore this is incorrect. Okay, this question, Amna. Okay, so in these types of question, we used Kirchhoff law to find the potential drop and then equate it. Now let's look some other types of question which can come under Kirchhoff law. Okay, so that is example 4. No, we have discussed up to example 5. These are some questions. So example 6. Example 6. Find the current. Find the current through each resistor. Each resistor. Okay. So note the question first. I'll tell how to deal with these types of questions. So here, the first important thing is to mark the current in each branch. So we call these resistors as branches. Okay. So we have to mark the current in these branches and then we can solve. It is always easy for us if we minimize the number of unknowns. So when we are marking the current, in the branches, if we think a little, if we analyze the circuit, think a little and then mark, it should be really easy for us. Okay, so now we have to find the current in each branch. I'll start here. What I understand is the current will flow through this 3 ohm resistor and then divide into 2. Okay, it will divide into 2. Let's say this current is I1. Then this current is I2 and this is I3. How many unknowns do we have here? In total, how many unknowns do we have? We have 3 unknowns. To solve 3 unknowns, how many equations do we need? We need 3 equations. Okay? Dealing with 3 equations is not that easy. Are you getting me? So let's try to minimize the number of unknowns. Do you know any relationship between I2 and I3? Using the current divider, can I tell if the current through this 6 ohm resistor is I, then through this will be 2I. Agree with me? So the current through 3 ohm resistor should have been 3I. Then only this is possible, right? Shahama, clear how I mark the current in each branch? Now, let's apply Kirchhoff voltage law. Let's apply Kirchhoff voltage law for any loop. You can apply for any loop. I'll consider this loop. In this loop, what is the total EMF? In this loop, using KVL, the voltage in this loop is 30, which is equal to the potential drop. So we have a potential drop across this resistor, that is 3 IR, right? 3I into 3 plus 2I into 3. So 30 is equal 9 plus 6, 59. I is equal to 2 ampere. So in the 6 ohm resistor, the current is 2 ampere. And in 3 ohm resistor, I'll name them. This is R1, R2, and R3. In R1, it's 2 ampere. In R2, it's 4 ampere. And in R3, that's 6 amperes. Amna and Shahama, is it clear how we mark the current first and second, how we found them separately? Okay, so here, can you give a try for this question? It's slightly different, but that's all right. Try to Mark the current properly. Okay, in this question, tell me from where shall we start marking the current? From 10-volt battery or 6-volt battery? Which one is better? So here the question is find the current through each resistor, find the current and potential drop drop across each resistor. Okay, so this is the question. Find the current and potential drop across each resistor. So Amna, what is the first thing? It is to mark the current. We have to mark the current in the branches. So my question was, from where shall we start marking the current? From 10-volt battery or from 6-volt battery? Which one would be convenient for us? Always, let's start from the higher potential, higher EMF. Okay, we will start from higher EMF and reduce the amount of unknowns. Okay, we will always try to reduce the number of unknowns. So I'll say the current here is I. I am starting from the 10-volt battery. Okay, the current is I. In this junction, current has to divide. Let's say we have simple I current through this. Then the current through this has to be I minus I. Agree? Because in this junction the current divides. Again, here the current will combine. The current through each branch will combine and become I. Okay? Now, apply Kirchhoff law for these two loops separately. Here we have two loops. So when you just write the equation, it is hard for us to find which loop you are writing equation. So we will name the loop A, B, C, D, E, and F. Now, how to name this loop? It is A, B, E, F, and again A. Okay. Shahama and Amna, have you all got this equation for this loop? Shahama? Okay, for the next loop, total EMF is 6. You don't have any drop over here. Here you have a drop. But what can you tell about the direction of current? Direction of current is in the opposite direction. You are traveling in this direction, but current is in the opposite direction. If I mark the arrow, if I mark the potential drop arrow, you will understand that when you are moving in this direction, the potential is not drop, but it rises. Potential rises. Therefore, we will write it as minus 8I minus I. Amna, is it clear why I had to use this minus here and Shahama? So, Shahama, you get the equation and simplify to get the answer. Amna, what we have done here is in this KVL, in Kirchhoff voltage law, what we do is we equate the voltage or the potential rise to potential drop. Okay, we equate potential rise to potential drop. So now all these batteries, we consider all these batteries as rise and we will write the equation. No problem with that. Now let's come to drop. I have a resistor. Can you remember this arrow, the convention we were discussing so far? If you if you meet this arrow in the opposite sense, then is it a drop or a rise? It is drop or rise. If your arrow is opposing the direction you are traveling. Now what is it? A drop or a rise? It is a drop, right? It is a drop. What if this is a resistor, but you are traveling in this direction, okay? When you are analyzing, you are traveling in this direction. Now, how should you consider this? As a drop or a rise? How should you consider this? You will have to consider it as a rise because the potential is increasing. What we show using this arrow, we show the potential. Let's say this arrow shows 2 volt. That means it is saying when we compare to this side, the other side voltage is high by 2 volt. Okay, so it is a rise. Now, if you are going to show a rise in the side of drop, in the sides we only include drop, but now you want to show a rise there. Therefore, can I show it as minus? Can I use minus to show rise in drop? I hope you are getting me. You didn't get it. Okay, here we have drop. Here we have to include only drops. But if there is a rise, then we can show it as minus, right? It is just like this. So this direction is positive. Just think about vectors. This direction is positive. Okay, can I tell the opposite direction is negative. The opposite is negative, right? So just like that, here also we have to include drops. But when there is a rise, I show it using negative. So here, when you are traveling in this direction, if you mark the drop, it will be like this, right? Because current is coming down. If you mark the drop, it will be like this. So if you are analyzing the circuit in this direction, it is a rise. So you use negative. So you don't need to think a lot when you are analyzing the equation. What you have to remember is, if the current in the resistor is in the direction you are traveling, okay, this is the direction of current, and you are analyzing in this direction, so if you are analyzing this direction, then it is positive. If the current is in this direction, but you are analyzing the opposite direction, then it is negative. Amna, is it clear? So you don't need to think a lot whether the potential is increasing or decreasing. Why I had to explain that deep is to understand why we have positive and negative. Now you can just look the direction of current and mark these signs. Okay. So put down the equation, simplify and find what is capital I and simple I. If you want, you can put a note, a small note, so you'll understand. The meeting might end. Join in